Hi guys, welcome to today's recording. We are going to go through the 2020 NCEA Level 2 2.6 examination today. So if you have been finding these videos helpful, please smash the like button, subscribe if you haven't. A large percentage, I think it was about 60 to 70% of the people that watch my videos aren't subscribed, so if you could do that for me, that would mean a lot. Okay, so let's just get started. So 2.6, a lot of it is a third of it is rate reaction, which is from year 11, and then you have equilibrium, and then you have acids and bases calculation. So you do need a calculator. All right, so let's just go through it. So question 1, we're looking at sodium hydrogen carbonate is a salt and dissociate into ions when dissolved into water. So we need to write an equation to show this. Process. So this is just looking at, let me just highlight it. So it's a salt and dissociate into ions. So that just means the NaHCO3 will dissolve into the ions. So you just split into the ions. And there you go. So these two ions are from your NCEA level 1 acids and bases in external, the table of ions. Surely we don't need to explain that too much here. All right, next part. One of the ions formed from the dissociates amphi product. So amphi product, it means you can either accept or donate protons. So it's actually quite good if you didn't know this. Amphi product is a terminology. So if something that can amphi product is like, think of amphibian, it can do both. A product means it can give away a proton or accept a proton. So when it is acting as an acid, so it's not I can tell you already, it's not this guy, because Na plus doesn't do anything. You should know that from redox, from a lot of things that you learned this year, that Na sodium ions as spectator ions, they're very, very stable. They don't want to do anything else. So it is going to be the H3O minus. So this is a test to see your understanding of the concept. So what is one is behaving as an acid, so that means it is accepting. Accepting. It's a bit late in the evening, my brain's not functioning too well. So if it is acting as an acid, so that means it's donating an H plus. If it is acting as a base, this is receiving an H plus. Okay, so what that means is that if you put this in water, it will partially dissociate. It gives away the acid, so it becomes CO3 2 minus plus 2 plus H3O plus, and then when it is accepting behaving as a base, it's going to take one of the H's here, so it becomes H2CO3 plus OH minus. Now be very mindful of these charges, because you're starting with HCO3 minus, you donate an H plus away, so you lost a +1 charge. That's why it became 2 minus, and that's why it is no charge over here, because you have gained an H plus, which neutralized that minus charge. Okay, now next part here, for BI, a solution of sodium hydroxide NaOH has a pH of 11.8. calculate the concentration of hydroxide easy. So if we know pH equals 11.8, so that means I'm going to use my method. So if you want to, if you aren't sure how to do pH calculations, refer to one of my previous videos on the pH calculations. I'm just going to do it the easy way. POH is 14 minus 11.8, which is equal to 2.20, and then the OH minus concentration is just going to be the 10 to the power of negative POH, which is 10 to the power of negative 2.2, and if you crunch that numbers into a calculator, it is going to be 10 to the power of negative 2.2, 6.31 times 10 to the power of negative 3 moles per liter. Now, if you are looking at this, you're like, what the heck did he just do? What is this POH stuff? My teacher never taught me. I just like to use this method because it's more friendly in terms of calculation. What you could do is that if you know the OH minus if you know the pH, you can go 10 to the power of negative pH to find the H3O plus concentration, and once you got that concentration, you can use 1 times 10 to the power of negative 14, which is kW divided by the H3O plus concentration, which equals the OH minus concentration, which is a longer method because you have to do more calculation. My way is you do a subtraction and then 10 to the power negative. That's much easier. Okay, next one, the ionization constant of Kw, like all equilibrium constants, vary with temperature. Calculate the pH of a pure water at 0 degrees when Kw equals 0.1. Okay, so they gave you Kw, so you know, Kcs and Kw, every K varies with temperature. So you can think of that, the what are we looking at? We're looking at water, aren't we? So water, that means the H3O plus and the OH minus concentration are the same. So that means Kw equals H3O plus squared. Yeah, so because these two things are the same, they equal, so it just means one thing multiplied by the same thing, it's just the same thing to the power of 2. Okay, so Kw equals 0.114 times 10 to the power negative 14. So what you want to do is say you want to square root this number. You know, this is math. If you need help with algebra, infinity plus 1, that's where you need to go. Okay, 0.114 times 10 to the power negative, and 10 to the power negative 14, square root this bad boy, then I get 3.38 times 10 to the power negative 8 moles per liter, and pH equals negative log H3O plus, so you are just going to negative log the entire thing, and then the pH is 7.47. Okay, so there you go, very straightforward, I hope. So it just shows you at 0 degrees water is not, you know, perfectly neutral because of the difference in the concentrations. All right, next one. C. The table below shows a concentration of pH of 3 basic solutions: sodium ethanoate, ammonia, and sodium hydroxide. And then let's just highlight them. So we got sodium ethanoate, we got ammonia, we got sodium hydroxide, and then their pH is given. Explain why these solutions have different pH values, yet they are the same concentration. Okay, so use equations. So we're just going to quickly go over them because I have the answers down there. So really quick, with your CH3COO Na, this is a can you see this is with the Na plus ion, so this is a mixture. So if you actually dissolve this is a salt. So if you dissolved it in water, you will separate the ions into that. And then if you look at CH3COO minus, hopefully after enough practice of this standard, you can see that it is the conjugate base of the ethanoic acid. All right, how many times have you seen CH3COOH? All right, so now for the first one, as you can see, the equation, the concentration is all 0.1. The pH is 8.88. So what does that mean? It is above 7. Why is it above 7? Because you have got a partial dissociation of one of the ions, further dissociate and produce a small concentration of the OH minus ions. Okay, so you have a small OH minus concentration from the dissociation, but then the OH minus concentration is still bigger than your H3O plus concentration, meaning that it is a weak base and the pH is going to be 8.88. That suits perfectly normal. Next one is NH3. NH3 in this case is also going to be a weak base. So it's actually quite good. These two are really good examples of weak bases. And people go, how do you know if something is a weak base or strong base in year 12? Just remember the weak bases is NH3 and CH3COO minus. Okay, just go with these. And then your NH3 interchanges to NH4 plus, and then your CH3COO minus interchanges to CH3COOH. Okay, all right, that's gonna fit. So ammonia is one of the most popular ones. You just need to know. Now, because the so if you look at this pH is 10.6. Why is this pH 10.6? Because if you compare this the OH minus that I just highlighted, which is this one, versus the one that I highlighted just now, the OH minus of the NH3 is going to be higher. The concentration is going to be a little bit higher than compared to the CH3COO sorry, CH3CO minus. That's why the pH is going to be a little bit higher. Last one, which is the sodium hydroxide. Sodium hydroxide is a strong base. That means it completely dissociates. into Na plus and OH minus. So that means there are heaps of OH minus concentration, because this is a complete dissociation. These other two are partial dissociation, therefore that has the highest pHs. Okay, so let's have a look at the answers. Let's grab a highlighter. So the higher the pH, that means the more hydroxide ion there are. So it's just, you know, common sense. But don't worry about the first paragraph, it doesn't really make much sense. Sodium hydroxide is a strong base, so that fully dissociate. You have tons of OH minus ions, very high OH minus, very low that, which means you have a high pH. And this is the equation here. All right. Now I didn't have time. I couldn't be bothered putting like doing the like say it should be, instead of Na plus, it should be Na plus plus OH minus. Yeah. Don't write it like this and come back, and you know, at the end of the year you do that in the exam and come back to me next year and say, hey, you told me this is okay. Well, I just can't be bothered formatting. Okay. Now NH3 is a weak base, so it partially dissociates, releasing fewer OH minus ions. And this arrow here, this is an equilibrium. You can refer to my my notes for the equilibrium, but I can't get an equilibrium sign onto OneNote. Stupid system doesn't like equilibrium signs for some reason. But CH3CONa, so first it dissolves, and then release a weak with the weak CH3CO minus, which then partially dissociate, but it produces not as many hydroxide ions compared to the other ones. So you know, so therefore it has a lower lower OH minus concentration and a lower pH. Okay, so hopefully that question makes sense, and that is the end of question 1. Let's move on to question 2. So question 2, I just look at this question when I see test tubes and equation. When I see this and this is just rate reaction. Yeah, I'm not even gonna bother watching that. I'm just gonna go straight to the question. Explain how the rate of reaction is affected by temperature, which affects the rate of reaction. Yeah, this is what happens when you've been teaching and doing the same stuff for too many years. You just, what is that? I don't even care. I just look at this. Yeah, one's 20, one is 40, one is 60. Well, this I wouldn't put a cross on it because there's some colors that we want. Phase and reaction is complete when the mixture looks colorless. So as you can see, 60 degrees it turns colorless after 45 seconds, 40 degrees is halfway, 20 degrees hasn't even started pretty much. And they just want you to talk about how temperature affects the rate of reaction. So you need to remember temperature. I think I recorded this before, but I can't remember. But with temperature, is that higher temperature results in two things. Higher temperature means two things. Means that first of all, there's more heat energy. Therefore, the particles have more kinetic energy. They travel with more kinetic energy, so they move around more. We can find like a long answer down below. They move around more, so that means they're more likely to collide. Okay, so more likely to collide, and therefore there's a higher frequency of collision because there's more energy, and then they bump into each other more. Okay, so that's one aspect. Now the other thing is because there's more heat energy, there's more kinetic energy. I should do that from here actually. Oops, let's get rid of that. There's more kinetic energy, so that leads to the other thing. So the other way goes to move around more likely to collide. Because there's more kinetic energy, so more collision, so higher proportion. They're gonna collide with more energy. And what that means is that a higher proportion of collisions will have sufficient amount of energy. Have enough energy to overcome the activation energy, if you want to talk about that more in a little bit more detail, and then combining that to those two together. As a result, there's a higher frequency. There's a higher frequency of successful collision. And then you're probably coming from last year, year 11, you probably go, hey, where's your per unit time? Well, I don't need to say per unit time because I said frequency. Higher proportions, okay, higher frequency. Frequency means per unit time. Okay, so if you look at the answers, it's quite long. Obviously, increased temperature means there's an increase in rate of reaction because there's more kinetic energy, therefore they move faster. Increasing frequency, exactly what I wrote, but just in the complete sentence. And the more these collisions have sufficient amount of energy to be successful, which means because they have more energy, blah 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 blah, there's really so greater frequency of effective collision. There you go. It's pretty much what I wrote, but just in a complete paragraph. But you just need to understand that with temperature, you need to cover both aspects. You can't just go, oh, it has more kinetic energy, therefore they collide more often. You're not going to get excellence with that. And to be honest, rate of reaction is one of the easiest ones to get excellence in this particular unit because of you did it last year. All right, and yeah, make sure you study it because it is very, very, very common that you get asked about temperature in terms of rate of reaction because concentration and surface area are both too easy. I mean, they were excellent in year 11 and they probably don't get to show up that often in year 12 at all. Right, next question. So this is pH calculation. All right, so 8 calculate this one. So this will just be 10 to the power of 0.89, 10 to the power of negative 0.89, which is 0.129. This is 0.129 moles per liter. This pH will just be negative log whatever that thing is, 0.0158, and that will just be 1.80, and this will be 10 to the power of negative 2.94, which will be 1.15 times 10 to the power of negative 3 moles per liter. Very straightforward. Now, that seems a bit easy. Yeah, that's it. All right, next one. 2 grams of powdered calcium carbonate is added to each of these solutions. Oh, yes. Okay, the volume of each acid is the same. So this is what I meant. Like they don't really give you concentration on a standalone question. They try to mix it up. You have to calculate. You have to calculate these concentrations first to actually know what the difference. You actually have to calculate them. Identify which solution have the highest rate of reaction with the calcium carbonate. Explain your answer with reference to collision theory. So it's obviously solution A. It's obviously going to be this guy. Why? Because it has the lowest pH, which means it has the highest concentration of H3O+. What does that mean? Because a highest concentration, therefore there are more particles, more H3O particles. Oops, I don't need the concentration there because more particles already means that. There's more H3O+ particles which are readily available to collide. Oops, more H3O+ particles per unit volume. And I'm not going to write the next one. I'm just going to say it because there's more particles per unit, more H3O+ particles per unit volume. Therefore, there's a higher chance for them to collide with the sodium carbonate. Oh, sorry, calcium carbonate. Therefore, resulting in a higher rate of reaction. Okay, so as you can see, this is year 11 excellence, but solution A is the highest rate of reaction because it has the lowest pH, which means the highest concentration of H3O+. Therefore, more H3O more particles per unit volume. Therefore, more frequent collisions. Therefore, more effective collisions per unit time. Okay, so there you go. Very straightforward. Next one, C. Compare the electrical conductivity of HCl and CH. Okay, so this is conductivity, this pH and electrical conductivity. These are the two major excellence questions. So you just need to remember HCl completely dissociates in water because water's conductivity depends on. Conductivity depends on the concentration of free moving ions or electrons, and we're not dealing with free moving electrons here. We're dealing with free moving ions. If you look at CH3COOH, this is a weak acid which partially dissociate. And have you noticed that the thing I said previously for question 1 that you only get certain combinations? This is that again. You just need to know it. Okay, so this is a strong acid. It completely dissociate. You have a large concentration of free moving ions, therefore it conducts electricity. Whereas CH3COOH is a weak acid. It partially dissociate, producing a small concentration of the free moving ions, therefore it's a poor electrical conductor. And that's all you need to say. Let's scroll down. So there you go. There's the equation I've done. So strong acid completely dissociate, producing lots of ions, and then conductivity depends on the number of free moving ions, and then therefore it's a good conductor. Whereas the other one, weak acid, partially dissociate, therefore not many ions, therefore it's a poor conductor. Very straightforward. Once you know what you're doing, the standard is really forgiving, if you ask me. So yeah, next one. Next one looks like a Kc expression. So when we do Kc expression, remember that we only include gaseous and liquids, gaseous and aqueous substances. So this is gas, so we can include all of them. So we do the Kc. Kc equals, remember, products over reactants, CF4 times CO2 divided by COF2, and then that coefficient of that big 2 at the front becomes the power. Okay, so that's your Kc expression. Now we're just going to calculate the Kc. We're just going to substitute numbers into the equation. So what's CF4? CF4 is 0.8, so it'll just be 0.8 times 0.8 divided by 0.04 squared, and that's going to give you, what is the answer here? Let me just find it. It's not a worthwhile equation for me to actually get a calculator. So Kc equals 400. Just find the numbers, substitute it in. It's really not that difficult. Next one, at a different temperature, Kc is 50. Explain what the value Kc indicates about the extent of this reaction. So remember, Kc is a product's concentration divided by the reactant's concentration. Yeah, and if you have a really big number at the top, let's say for example 50 divided by 1, that's going to give you 50, isn't it? So that means you have a lot of products and you have very few reactants. Okay, because remember Kc is a mathematical ratio. It just means that if your Kc is larger than 1, there are far more products compared to reactants. And therefore the forward reaction is being favored in this case. And that's what you need to say. Okay. Next one, the enthalpy change for the decomposition is negative 24 kilojoules per mole, and explain what happens to the value Kc when the temperature is decreased. Okay, so we actually need this equilibrium. Let's just, can we copy it down somewhere? It's 2COF2. Let me just write it here. So 2COF2, I'm just going to rewrite the equilibrium so we can use it here, plus CO2. So they told us the enthalpy for the decomposition of carbon and fluoride, this is negative 24 kilojoules per mole. Okay, and if you wonder where this came from, this is just from the equation. This is the equilibrium from the first part. Okay, now what are we trying to do? The enthalpy change is negative 24. Explain what happens to the value of the Kc when the temperature is decreased. So this is one of the videos that one of the questions, the type of question I explained before, guaranteed excellence question. Fully test you to see what you know, if you understand Kc and Le Chatelier's principle. So let's just break it down again. So the forward reaction is exothermic, so just remember that. Yeah. Now when the temperature, so the question asks, the temperature is decreased. So you have a decreasing temperature. If you decreasing temperature, that means the system is going to minimize that change. The system will favor the, if you're decreasing the temperature, if you're making the container colder, the solution want to release some energy to replace some of the heat energy that has disappeared. The solution will favor the exothermic reaction. All right, they will favor the exothermic reaction to release. They want to release some heat energy. They want to release some heat energy to replace, to minimize this change. Yeah, obviously you have a more detailed answer down there, but this is the thought process. If we decrease temperature, how do we minimize it? Because the Le Chatelier principle, again, I have a really full on half-an-hour video if you want to watch that. If you decrease temperature, you want to reverse the change, and in this case, yep, it's taking away some of the energy. We're going to release some energy back in, so we favor the exothermic reaction. And we know the forward reaction is exothermic because the question told us the forward reaction XO, therefore the forward reaction is favored. The forward reaction is favored, and as a result, the concentration of CF4 and the concentration of CO2 increases, and then the concentration of COF2 will decrease. The concentration of COF2 decreases. So the Kc, remember, is products divided by reactants. Now, because we have more products compared to reactants, Kc would increase. And there you go. That's your answer. Okay, so let's have a look at how they worded here. It's more, this question doesn't require you to write a lot. It's more of the thought process. Because the reaction is exothermic, that's what the question told us. Temperatures decrease, the reaction move favors the exothermic reaction to produce some heat energy to minimize the change. And therefore, for the full reaction, that means you make more products, therefore Kc increase, because Kc is products divided by reactants. Okay. I think this is towards the end. Second last question. How are we going with time? 25 minutes. Let's get a bit long. Let's keep going. All right. So the following equilibrium was established in laboratory, mixing blah 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 blah. Reaction produces heat. The forward reaction produces heat. That's important. That means the forward reaction is negative exothermic. Okay. So if the forward reaction is exothermic, the effect of the color, if more potassium, so more KSCN is added in. Okay, so let's just look at the colors. I mean, you'll be nice. Oh, the colors right here. I'm just blind. The colors right here. Okay, so more KSCN added. So let's think about this equilibrium here. And this is where people again get confused. If you're getting confused, it's not because you don't understand Le Chatelier's principle. Some of you just don't understand spectator ions. When you're adding KSCN, just break it down to the ions. One is K plus, one is SCN minus. The K's and NA's never do anything. It's always spectator. They're always spectator ions. So it's always sus. So essentially, adding more of this. So think about it. This concentration is going to increase. Yeah, if that concentration increases, how does a system, and therefore the system is no longer at equilibrium, how does a system minimize that change? How do they reverse what we did to this particular system? It will want to get rid of the extra SCN minus that you added in. So what the system will do will shift to the right, to use up the added SCN minus. Yeah, so as a result, the FeSCN2 plus concentration, this will increase, and then the Fe3 plus concentration will decrease, and then the SN minus will probably decrease a little bit compared to how it was, Therefore, you have more FeSCN2 plus, therefore it's going to be more red. All right, so that's just Le Chatelier's principle. So here we go. So adding thiocyanate, which is KSCN, adding that means there's an increase in concentration of the reactant. The system shift to the right, favor the full reaction to get rid of the added SCN minus, producing more red. Therefore the color will become more red. Nice and easy. This is the last question. Yeah, nope, two more. Sodium fluoride is added to the solution. The added F minus react with the Fe3 plus ions. All right, I need to steal my equilibrium. Where's my equilibrium? Can I steal this? Let me just. Does that work? Yes, legend. Okay, so let me just complete this equilibrium. There you go. FCN, does charge work out? This needs to be 2 plus. Okay. Let me just double check. Yes, that's right. Clever. All right, so we want to, so the added F minus react with the Fe3 plus. So you add the F minus, which will react with the Fe3 plus concentration. So when you're adding the sodium fluoride will react with the Fe3 plus. So as a result, the Fe3 plus will be, this concentration will decrease because it's being reacted with the F minus. Okay, so if the Fe3 plus concentration decreases, what does the system do to minimize the change? It will shift to the left or favor the reverse reaction to make more Fe3+ ions, to replace them. So what does that mean? That means there's the SCN- concentration increases, and then the FeSCN2+ concentration decreases because you're shifting this way, so you make more of this guy. So and what color is FCN-? So you'll become more orange. It will be less red, more orange, less red, more orange. Okay, just, you know, colors. The colors is just, and you don't, the color bit, don't get confused with that. It's just to tell you, you know, which concentration is increasing, which concentration is decreasing. What do you have more of? What do you have less of? And what color is the one they have more of? Right on the color. All right, so because added fluoride react with the Fe3+ ion, so decrease in concentration, Fe3+, which means it's no longer equilibrium. It shifts backwards to favor the reaction. Well, uses up the red FeSCN2+. That means the light, the dark red color will lighten up, and then you will get more orange color. All right, last one. Now, a test tube containing the reaction is placed in a beaker of recently boiled water. So boiled water, what that means is that you're increasing temperature. You're increasing temperature. Now we have established, you know, from the question, let me just quickly scroll up, the bits are highlighted here, which is very, very underrated. This bit here, the forward reaction produces heat. So that means, let's go find it here, where it is. So increasing temperature, so that means the forward, let's just write it down before we forget. Just copy it. Oops, can I copy it here? Of course I can. Let's drag it this way. All right, so 2+. So we know the forward reaction is negative because it produces heat. Okay, so if we are putting it in a beaker of boiled water, so we are increasing temperature. So how does the system react to that? The system will shift. The system will shift to the side with, well, I won't say to the side, will shift to the endothermic reaction to absorb the extra heat energy. Okay, so you just need to, you know, it's more of the thought process that matters here. You need to understand we're changing something to the system, and how does the system respond? How would they minimize that change? So if you're putting in hot water, you're increasing the heat energy, and they will be like, how do I get rid of that heat energy? We just suck it in. We will do a chemical reaction that will require energy, and we will use up the extra heat energy, so they will favor the endothermic reaction. We know forward reaction is exothermic, so that means the is going to favor the backwards reaction, favor the reverse reaction. So that means the concentration of Fe3+ and the concentration of SCN- both increases, and then the Fe3 or FeSCN2+ concentration will decrease. That means it will be less red, more orange. Okay, so this is temperature. So again, when reacting produces heat on hot water, so the reaction moves to endothermic reaction to absorb the heat energy, therefore it favors the backwards reaction, therefore you make more of the orange stuff, use up the red stuff, which makes the color will lighten, and you are going to do really well in the end of the exam because you have listened very you know, carefully to this particular video. Okay, so hopefully this has helped. Question wise, I think this is very standard, nothing in there that's out of the ordinary, and it just you just need to understand, especially with the Le Chatelier's principle, which way does it shift, why does it shift that way. Calculations in acids and bases are quite straightforward, and then the rates reaction, just make sure you get more than an A4 than what a lot of people do, because they miss out on the merit and excellence due to wording. Okay, so as always, smash a like, hit subscribe if you haven't, and I'll see you guys next time. Bye bye.